Imagine looking down at the ocean floor and seeing an army of legs crawling across the seabed, millions of them. Not ants, not fish, crabs. Giant crabs marching together like they're headed to war. But they're not fighting, they're migrating. And not just a few of them, we're talking about one of the largest crustacean movements on the entire planet. These are snow crabs and king crabs, two of the most iconic and oversized species found in the icy waters of the Arctic and North Pacific. But here's where it gets weird. These crabs aren't just moving, they're also growing. A lot. The colder the water gets, the bigger they seem to become. Some king crabs reach over 20 pounds with leg spans wider than your car's steering wheel. But why? Why does cold water make sea creatures gigantic? What force is pulling millions of crabs across the seafloor every year? And if this underwater migration is so massive, why do so few people even know it's happening? To figure that out, we have to follow their trail through freezing waters, prehistoric instincts, and a biological mystery so strange, it may change how you think about life in the coldest parts of our planet. If you thought birds had the wildest migrations on Earth, you clearly haven't looked at the ocean floor, because beneath the waves, there's a slow-motion stampede happening that almost no one ever sees. And it's led by snow crabs and king crabs, two of the most mysterious crustacean giants alive today. Each year, these crabs begin a massive migration across the seafloor. Not in small groups, not in isolated regions. We're talking about millions of crabs moving together in synchronized waves, crawling over sand, mud, and rock like a living tide. In places like the Bering Sea, researchers have spotted crab masses so dense they look like underwater carpets stretching for miles. But they're not doing it for fun. Crabs migrate to find food, escape predators, molt their exoskeletons, and most importantly, mate. Some migrate to deeper waters to avoid warmer summer temperatures, while others head shallower to spawn and release larvae. Their direction shifts with the seasons, and their routes can span over 100 miles depending on depth, currents, and temperature. And because these migrations happen deep underwater, sometimes hundreds of meters down, humans barely notice they exist. You won't find drone footage of it, you won't see it in travel documentaries, but it's happening constantly across the icy northern seas. King crabs are like armored tanks, slowly bulldozing their way across the bottom. Snow crabs, on the other hand, move more like swarms, lighter, faster, and able to pile on top of one another in what's called crab clouds. And yes, that's a real term. Scientists studying them have described seafloor footage where it looks like the sediment itself is crawling. What's even stranger is that these migrations aren't totally random. In many species, females migrate separately from males, and even molt at different times. When it's mating season, entire armies of male crabs will chase down females across the seafloor in slow-motion pursuit. You'd think it would look like a crustacean romance novel, but it's more like a giant, slow-motion mosh pit. But now, something is shifting. In recent years, snow crabs have vanished from entire regions. Populations have collapsed, and scientists are scrambling to understand what changed in one of the most predictable migrations in the animal kingdom. At first glance, cold water seems like the last place you'd expect anything to grow massive. It's dark, it's freezing, and food can be hard to find. But in the ocean, cold doesn't shrink animals, it supersizes them. And for cold-blooded marine species like snow crabs and king crabs, the chill is exactly what gives them their size. This phenomenon is part of something scientists call polar gigantism, a biological effect that happens when animals live in freezing, oxygen-rich environments. You'll find it in crabs, squids, sea spiders, and even jellyfish. But why does it happen? It all starts with the water itself. Cold water can hold a lot more dissolved oxygen than warm water. And for animals that breathe through gills like crabs, more oxygen means their bodies can grow bigger without starving their cells. On top of that, cold water slows their metabolism, so they burn less energy just staying alive. That means they can afford to build bulkier bodies and maintain them for much longer than in warmer climates. The result? Some king crabs grow shells over a meter wide, with massive legs built for deep-sea roaming. And while snow crabs aren't quite as thick, they still grow large enough to dwarf your average land crab. In warmer waters, that kind of size just isn't possible. There's not enough oxygen, and energy gets used up too fast. But in the cold, everything changes. And the benefits go way beyond just looking intimidating. Larger size means thicker shells for defense, bigger claws for grabbing prey, and longer legs that help them move efficiently across vast stretches of seafloor. It also allows for better energy storage and heat retention, two major advantages in the deep. Oddly enough, this rule doesn't work for warm-blooded animals. They can't use dissolved oxygen in the same way, and their bodies constantly burn fuel to stay warm. That's why polar bears, seals, and penguins are big but not absurdly big. Their size is capped by how much they can eat. Crabs, on the other hand, let the cold do the heavy lifting. So next time you see a 20-pound king crab, don't just think seafood. Think about how temperature alone turned a small crustacean into a deep-sea titan. If snow crabs and king crabs look like they came from different planets, that's because they kind of did, evolutionarily speaking. One is built for power, the other for strategy. But both are products of the same cold water gigantism effect. And while they often get grouped together, these two crustacean giants aren't even in the same biological family. Let's start with the king crab, the undisputed tank of the seafloor. Massive legs, a thick armored shell, and claws that could easily break a finger. Some species grow over 24 pounds, with leg spans stretching wider than a bicycle wheel. They evolved from hermit crab ancestors, but traded the shy, shell-hopping lifestyle for full-on brute strength. They're slow, but they don't need speed when you're built like a mini-monster truck. In their cold, rugged environments, power is protection. Now meet the snow crab. Smaller, lighter, and much faster. While most weigh in around 2 to 4 pounds, they make up for it with agility, adaptability, and sheer numbers. Their bodies are built for deep, frigid environments where flexibility and speed matter more than brute force. Snow crabs can swarm, stack, and even migrate in dense formations called crab clouds, which sounds like a joke, but it's absolutely real. Don't underestimate them though. Snow crabs still grow massive compared to most other crabs, and their claws, while slimmer, are precision tools made for snatching prey and defending territory. In colder environments, they reach larger sizes and reproduce faster than their tankier cousins. So who wins in a fight? It really depends. In a 1v1, a king crab's sheer mass and armor would easily overpower a snow crab. But in the open ocean, numbers and speed matter. In swarms or mobile migrations, snow crabs might be able to overwhelm or outmaneuver even the biggest king. What's fascinating is that these two giants rarely even cross paths. Snow crabs dominate the deeper, colder zones of the ocean, while king crabs claim the shallower slopes and continental shelves. It's almost as if evolution gave them each their own biome to rule like two kings in different kingdoms. They're not just rivals. They're parallel success stories, two versions of what gigantism can look like, depending on how you play the game. So if cold water builds giants, what happens when the cold disappears? That's not a hypothetical, it's already happening. In recent years, Alaska's snow crab population suddenly collapsed. Millions vanished almost overnight. And one of the theories, the ocean got too warm. With less oxygen and faster metabolism, these crabs may have literally starved despite being surrounded by food. Their bodies just couldn't keep up. King crabs are facing similar problems. Warmer waters are pushing them into deeper territory, changing migration patterns and collapsing local fisheries. These aren't just population dips. These are full-on ecological rewrites in real time. The rules that built the giants of the deep cold, stability, and oxygen, are starting to break. And when the water warms, the blueprint for gigantism vanishes. The crabs that once ruled these seas might not be able to survive the very ocean they helped define. But this isn't just about crabs. It's about how fragile even the toughest giants can be. Because if the deep sea changes, everything else changes with it. Thanks for watching. If you're curious how polar oceans create other monster animals like jellyfish and squids, check out our video on polar gigantism right here. And don't forget to like and subscribe for more deep sea breakdowns.